Okay, friends, we're rocking this one. I'm so excited. This is the last part. This is 11.4a notes, but really it's a continuation of 11.3 because we're still talking about angles, and these are the type of angles that are formed here by what's called a chord angle. Now, here's the big deal. Remember, as someone said, hash mark heaven, a little overdosage. Okay, I'm with the overdose of hash marks. There used to be called pound signs when I was a kid. It says the key to finding the measure of an angle in a circle is to know the location of the vertex. The location of the vertex tells you how many arcs and what to do with it. So this next one is called a chord angle, but the problem is when you have a chord and it intersects inside the circle and not on the center, you actually end up getting 4 angles now. So you have to know which angle you're working with and then realize you're going to get some unique intercepted arcs. So for this angle 1, your intercepted arcs end up being 2 of them. You're going to have the one for the angle itself, but you also have the one for its vertical angle, because what do we know about vertical angles? They're congruent. So now we have a little bit different calculation process. So let me tell you what it is. If 2 secants or chords intersect in the interior of a circle, then the measure of each angle formed is half the sum of its intercepted, of its 2, I'm going to say 2 here, intercepted arcs. So I'm going to call this one x degrees, and I'm going to call this one y degrees. What means now I have to look for 2 anytime it's inside and not on the center. So when I get that, I'm going to 1/2 of x degrees plus y degrees. Alright, now with this, let's apply it a little bit. Now again, looking at these diagrams, do you guys see the vertical angles in the linear pairs? So don't forget to use those to your advantage. Now the first one I'm looking for is angle AEB. It has 2 intercepted arcs. The one for the angle itself, so I'm going to mark that real quick. It's going to be right here. And then one for the vertical angles intercepted arc. Isn't that kind of fun? Alright, now I'm nerdy. I thought that was fun. I'm marking stuff up on a circle and I think it's fun. But it's true, it's cool. So those are my 2 intercepted arcs. So to find the measure of angle AEB, or you could say angle DEC in this case, it's 1/2 their sum. So I get 1/2 of 252. So 1/2 of 252 is going to be 126. So let me put that down here real quick. So it's 126 degrees. Now remember, that's 126. That makes this 126. And then you have a linear pair. So let's use that to our advantage for the next problem. Now, again, ask yourself the question, what do I have? Ooh, I have circles and angles and arcs. What do I want? I want the measure of 2 angles. I want ABD's measure, and I want ABE's measure of those angles. So to do that, I am going to have to work with, again, where the vertex is located. The vertex is in the inside, so I automatically know that I have 2 intercepted arcs. Now I can't use the intercepted arcs for ABE because I don't know their measures, but I can quickly show, like here and here, that's one for the actual angle, and then you have to do it for the vertical angle also. And then I apply my theorem I had up there. The measure of angle ABD is 1/2 the sum of the 2 arcs. So sum is addition, 65 plus 37, so I get 1/2 of 102, and so that'd be 51 degrees. So this is 51. Well, what do I know about these 2 angles? Well, they're supplementary because they're a linear pair. So the measure of angle ABE is 180 minus 51, and it's going to be 129 degrees. All right, hopefully that helps us on this page.